everybody, this is Chris. This is a follow-up to my video, The Foot-Powered Lathe. I'm going to do three things today. Answer your burning questions, show you some recent projects I've done, and get into more details of the lathe design. Now first I'd like to thank the nearly 9,000 new subscribers I've gotten since I launched this video. Who'd have thought a woodworking video could be the most viewed video in the world for just one day? 640,000 views. Thank you. First burning question. What did I actually make? This is not a bat to be used in the zombie apocalypse. And this is not a leg for a table. This is a handle to be used with a very large chisel called a slick, which is used in making log cabins. It's also meant to be disassembled so you can fit it in a toolbox. Second burning question, and this is my question. Why do people compare me to Ron Swanson? I don't look like this guy at all. But I did some research and I found out he's a character on the show Parks and Recreation, and in the show and in real life, he's a woodworker. So I take that as a compliment. Third burning question, and last one. How long did it take me to build the lathe? It took about 9 months. I have about 100 hours into it. Most of the time was spent building 3 prototypes. The funny thing is I didn't intend to build a lathe at first. It's really about making a contraption to drive some grinding stones that I had acquired. Let's take a look at the first prototype. Here's a very rough mock-up of the contraption I want to make. And so very roughly, as I turn this, it should drive everything. And this also could be extended into a lathe if I wanted. After my first prototype, I decided to focus on building a lathe. And so I went online to search for some designs. I found a great design on a website called manytracks.com, how to build a Treadle lathe. And this gives you all the dimensions, pictures, and instructions to build a really great Treadle lathe. And so my second and third prototypes basically followed this design. Check them out. After the third prototype, I decided to make some design changes for 2 main reasons. First, I want to be able to incorporate as many of the parts I'd collected as possible, like the Dunlop lathe. And 2 is just the fact that I don't use power tools, screws, or bolts. I had to really think through how the design was going to come together. You know, you really have to look for elegant solutions. Elegant solutions for me are where you have several parts that come together and interlock all in one step. So let's look at 3 of the elegant solutions I think there are in this design. The first and most challenging elegant solution was to connect the vertical section of the lathe to the horizontal sections. This is what I call the tower, and this is what contains the flywheel and pulleys. Now let's do a quick review of what that design was. In this case, these wedges, which come up from the base, draw the tower down to the base, and at the same time I integrate in this horizontal section so it all comes together in one step. The second elegant solution is where I attach the working table to the tower. Let's take a look at that joint in more detail. In this case, the elbows from the working table lock in with the side-to-side supports, and this tongue and wedge draw the tower into the working table, all in one step. The third elegant solution is this cross support. Let's take a quick look at the design. In this case, I use tapered pegs so this is easily disassembled. I can disassemble this entire lathe in just a few minutes with no more than a hammer and move it to wherever I want. I used heartwood on this for 2 reasons. One is I got it for free. A friend of mine had it in his barn for about 20 years and gave it to me to use. Secondly, heartwood is an extremely stiff and dense wood which provided great support. I know this because it took me about 30 minutes to rip it with a handsaw. Now let's look at one recent project I've completed and one that's in progress. This is a large wooden bowl I'm working on. I've made a couple changes to the lathe to account for such a large piece of wood. First, I've installed a thicker belt so it won't break. Secondly, I've replaced the small flywheel with a much larger flywheel to keep the momentum going while I'm working on this. I have to say this is a real challenge. When you're working on the outside of a bowl, it takes a lot of leg power to keep this thing turning, even for me. But it's going well. Now I'm going to take you through some other design elements where people had the most questions. In my first prototype, I simply had a big bolt acting as the idler. What I found recently is a belt idler from a Chevy 2005 Suburban, and this works great. It's easy to adjust and it's very low friction. So I've taken a skateboard wheel and ground out a lot of the material, and so here's one idler option. And then another one is to take an inline skate wheel and grind out a lot of the material. And you can see with both these, it's easy to mount on a shaft or a bolt in tight spaces, so we'll have to see which one works the best. This is the final idler design. It's intended to be a floating idler, so it moves based on the tension of the belt. The fact is this whole unit is way too heavy, and so it basically always goes to the down position, but it actually works quite well. If I were to do this again, I'd use a much lighter setup and maybe some type of spring-loaded action, so it could be a floating idler. This tailstock has a dead center, so it's still way too much friction for a foot pedal lathe. So I need to figure out how to turn this into a live center. If you do want to make modifications to the dead center, you need to get this whole unit out. You do that by screwing this through. The handle pops right off then. You screw it this way, and there you go. What I did was buy a couple Morse Taper 1 reamers from eBay. I had the shaft reamed out to fit this Morse Taper 1 live center, which I bought at Woodcraft for about $18. And I just put it back in the stand here. I'll tap the handle on later, but then you can see, here I have a live center, ready to go. I built this wooden mount so I could work on pieces larger than 8 inches in diameter. In fact, I can now work on pieces up to 20 inches in diameter, like a large wooden bowl. Let's take a quick look at the design. There we go. Now, if I want to move it, I just loosen this up, slide it, tighten it up, wherever I need to. Now I can work on much bigger projects. In this case, I reused the Dunlop lathe design, except with an extended bolt. So now I can attach the live center to the base using this thumb screw. I've added the thrust bearing here to account for the horizontal forces you get when you tighten down your piece against the live center. I've also added the second bearing here for more support when you work on heavy pieces like a large bowl. One of the things I don't like about this setup is that once the flywheel gets rolling, that power transfers back to the foot pedal, and the foot pedal continues to oscillate up and down even when I may not want it to. So I'd like to install a clutch on here such that when I'm pushing on the foot pedal it drives the flywheel. But when I'm not pushing on the foot pedal, it stays in place, but the flywheel continues to spin. And an application for this is called an overrunning clutch or a freewheel. An example of this is the back of a bicycle. When you pedal, it drives the tire, but when you stop pedaling, the tire spins, but the pedal doesn't. So I'd like to install something like this on my lathe. Well, to my daughter Rachel, I got a little overexcited. Looks like you're getting a new bike. But look what I got from it. This is exactly what I'm looking for. Now what I need to figure out is how do I attach the drive shaft for the flywheel to the drive. I'm not even sure this is going to work, but there's got to be another application similar to this. I really don't like the fact that it makes so much noise, but I'll give it a shot. The journey continues. Here's how I attach the drive to the flywheel shaft. I've got the shaft drilled and then tapped to accept the shoulder bolt. Then the shoulder bolt fits in there. Then I just screw it right on. Then I've also got a set screw in here to make sure it doesn't back out. And there you go. I've discovered the weak point on my design, and that's where the rod connects to the foot pedal. This piece here basically snapped right off. It wasn't intended for this much force, so I've done a temporary repair and I have to figure out if I'm going to weld this or I might just leave it the same. The final foot pedal design allows me to use both feet. And for the wood-to-wood contact surfaces, I coat them with paste wax to lubricate them. I hope you enjoyed it. Thank you. Hey everybody, this is Chris. Hey everybody, this is Chris. It's time to... Can you quit making so much noise up there? Yes. No.